Hello, hello, hello. We are gonna do some more pre-calculus. Yay! And we are gonna do, you're gonna be very excited to learn, chapter 2.7, which is solving equations in one variable. Hooray for only one variable, because two variables, it can kind of suck a lot. And so this is what we're gonna work on here in section 2.7. And let's see, new. And the kind of functions we're gonna do this with are referred to as rational functions. And that means that the function can be represented as a ratio of two functions. Oops. That's what makes them rational, is that they're a ratio of two functions. Rational numbers, on the other hand, which has nothing to do with this chapter, a rational number can be represented as an integer over an integer, p over q. Not necessarily an integer, just a whole number divided by a whole number. So square root of 3, for example, there's no way you can write this as some kind of fraction. Square root of 3 goes on forever, 1.7, blah, 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 never stops. Okay, same with square root of 2. Not true with square root of 4. 1/6 goes on forever. Punch that into your calculator. I think you get 0.1666666, maybe, something like that. It goes on forever, but it can be represented as a ratio of two whole numbers, so it is a rational number. If you can't represent it like that, it's irrational. And none of that has anything to do with the chapter here. I don't know why I bring it up, other than it was so interesting and you're grateful that I did. Okay, so we're going to be solving rational functions. And there's a rule with rational functions. You cannot divide by 0. If you do, it is no longer rational, so that's bad. So we have to look out for that. Okay? So here's the first example. This is example 1 in your book, maybe. I'm looking at the 8th edition here, but we're using the 10th edition, so the examples might be a little different. But that's okay. So x plus 3 over x equals 4. So part of this chapter is to give you some strategies for solving equations that we're going to apply throughout the rest of the time in our class. Okay? And I've learned through all of my years of teaching and studying math that denominators suck. If you have something in the denominator, it's hard to get to it. It's very inconvenient. So I always like to clear out denominators whenever I can. And for this x down here, if I want to get rid of it, I'm going to multiply that side by x and this side by x. And when I distribute, I'll get an x squared. When I distribute here, the x and the x will cancel, and I'll just get a 3. And then over here, I'll get a 4x. Okay, now I'm going to move the 4x to the other side. X squared minus 4x plus 3 equals 0, and hope this can be factored. So let's say 3. The factors are 1 and 3, 3 and 1. I guess I don't have to do that. Oh, -1 and -3. -3, -1 is the same thing. So does this add up to -4? No. Does this add up to -4? No. Does this add up to -4? Yes. So this can be written as x minus 1, x minus 3 equals 0. And let's test it just for fun, because it is a lot of fun. X squared, first 2, outside 2, inside 2, last 2. -1 times -1 is a +3. So this comes out to be x squared minus 4x plus 3. So it worked. Hooray. So I just wanted you to be convinced here, but now let's look at our function. What are the solutions to this equation? Well, it's x minus 1 equals 0, or this one, x minus 3 equals 0. So x would equal 1 here, x would equal 3 here. Oh, we got our solutions. We're awesome. But now, because of the kind of rational functions we're dealing with, we need to go back and make sure we're not going to divide by 0. So I need to take these numbers and go to the original function. And the original function was x plus 3 over x equals x. So the only way I could have divided by 0 is if I'd gotten a 0. And I didn't get a 0. So that's great. We can use all of those. Okay, so clearing out the denominators is a really useful thing to do. Okay, let's do, I don't know what that one is. Let's do this one. 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. I guess I don't need those parentheses, do I? Whatever, I'll leave them. Okay, so I want to solve for x. And you're probably thinking, holy crap, Mark, are you trying to kill us? What's the deal? And no, I'm not trying to kill all of you, but this looks terrible, but it's not that hard. First of all, we have some denominators. What are we going to do? And forget about this for a minute. If I'm adding 1/7 plus 1/3 equals, I don't know, equals x. If I want to get rid of the denominators, normally we'd get common denominators, right? But let's say I just want to get rid of them completely. So I would multiply this one by 7 over 7, right? Or no, I'd multiply this one by 7 and it'll cancel. But if I multiply, I got to do it to everything. If I multiply this one by 7, it won't cancel at all. But if I multiply by 3 times 7, and this one by 3 times 7, and this by 3 times 7, the 7s will cancel, and I'll get left a 3. The 3s will cancel, I'll get left a 7. And I'll get over here, 7 times 3 is 21x. And now we can solve this easier. So we're going to do the same way with polynomials. If I want to clear the fractions, I know on this side, I'm going to have to multiply by x minus 1 times x minus 3. When I do that, I know I'm going to get rid of this denominator and I'm going to get this denominator. But over here, I have to multiply by x minus 1 times x minus 3 as well. Now, what do you think the odds are that this thing is the factors of this? Yeah, it's very likely because these problems are set up that way. Because if you can't cancel out this denominator, this whole thing becomes a gigantic mess to solve, and it's very, very difficult. So the odds are the factors of this are x minus 1 and x minus 3. And in fact, this was the last one we just did, right? So this is, so x squared minus 4x plus 3. If I want to make 3, I can do 1 and 3 or minus 1 and minus 3. So the only two ways I can do it. And these will add up to give me minus 4. So this is x minus 1 times x minus 3. So I can rewrite this x minus 1 times x minus 3, but it doesn't matter because it's going to get canceled out. So when I multiply into here, the x minus 1 is going to cancel with this one, and we're going to leave behind an x minus 3. It's really important you get that. Let me write it out in gory detail. So I'm going to have x minus 1 times x minus 3 times 2x all over x minus 1. Plus, then I'm going to multiply it here. X minus 1, x minus 3 all over x minus 3 equals, I got to get rid of this stuff. Sorry, goodbye. Equals 2 over, I'm going to write this in factored form. x minus 1, x minus 3 times x minus 1, x minus 3. So now you can see these are going to cancel. And these will all cancel. So we end up with 2x times x minus 3 plus, that's an x minus 1, right? Yep. Equals, cancel, 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 2. Now we got to multiply. 2x squared minus 6x plus x minus 1 equals 2. So this is 2x squared minus 5x minus 1 equals 2. I'm going to subtract 2 to both sides so I get a 0 over there. 2x squared minus 5x minus 3 equals 0. Okay. Now we got to factor this or complete the square or use the quadratic equation. I'm going to try to factor it. And let's get rid of this here. See if I can explain how to do this. So I'm aiming for a minus 3. So I'm going to write the factors of, oops, minus 3. So it's 1 and negative 3, negative 1 and 3, right? But now I have a 2 being multiplied. I'm going to have a 2x and then an x. And I don't know where the 1 and the 3 are going to go. So the 2x might be multiplying by the 3, or the 2x might be multiplying into the 1. We don't know. So we got to look at our little factors here and figure that out. So if I put the 2 so it multiplies into the 1, let's see, this would give me, this times this is a 2, minus 3 does not give me a minus 5. This times that is a minus 2, plus 3 would give me a plus 1. So that doesn't work. So I'll put the 2 over here. So if the 2 multiplies into the 3, 2 times negative 3 is negative 6, plus 1 is negative 5. Oh, that looks like that'll work. So I got to think about this really carefully. So I want the 2 to multiply into the negative 3. So I want the negative 3 here. So it'll be 2 times negative 3. And then I'll put the plus 1 here. So I'll get a negative 6x, and a plus 1x will give me negative 5x. So then we go through and solve this, and I get 2x plus 1 equals 0. So x equals negative a half. And here, x will be equal to 3. So there we go. Those are the solutions. Man, I am so awesome. I don't know what to do. Uh-oh. We need to now check for what are called extraneous solutions. Those are solutions that either cause you to divide by 0 or cause you to take the square root of a negative number. If either of these solutions do either of those, it's considered an extraneous solution and you got to throw it away. So let's check. Negative 1/2. We got an x minus 1. That's okay. X minus 3. Yeah, that doesn't do anything. But we got an x equals 3. So if I plug 3 into here, yeah, I'm not upset by that. If I plug a 3 into here, I get 3 minus 3 is 0. And x minus 3 is one of the factors of this polynomial. So if I plug 3 into here, it's going to make that thing go to 0 too. So x equals 3 cannot be used as a solution. So the only solution we have here, the only allowable solution, is x equals minus a half. It's really important you understand that. We take the solutions, we go back to the original function and look to see if one of those solutions will cause us to divide by 0 or take the square root of a negative number. If any of the solutions do that, then they got to be thrown away. It's possible, and it happens, I think, in the homework, that you might have both solutions cause something to be divided by 0. It's possible neither of these solutions are allowed because of the denominators. if that's the case, then the answer is there's no solution. There's no solution to that equation. So in this chapter and from here on in the course, you got to check your solutions to make sure you don't cause either of these two and break the unforgivable law. Okay? So this is what this chapter is about. It's about extraneous solutions. Solving the equation and checking to make sure you're not going to blow anything up. Because blowing up equations is wrong. Wrong, wrong, wrong. Okay. Here's another example. X minus 3 over x plus 3 over x plus 2 equal, plus 6 over x squared plus 2x equals 0. So I'm probably going to multiply by x times x plus 2 to get everything cleared out. What is the likelihood x times x plus 2 are the factors of this thing? Yeah, really good. Because if it's not, the problem's probably impossible. So let's see. If I take x squared plus 2x, I can factor an x from each term, and I end with x plus 2. What a coincidence. It's the same as those factors. Who would have thought? Okay, so I'm going to replace that right now because it is a lot easier when I have it in factored form. Okay, so to get rid of the denominators, I'm going to multiply this by x times x plus 2. I'm going to multiply this by x times x plus 2. And I'm going to multiply this by x times x plus 2. I always write out the factors because you want to see where you can cancel them out. Okay, x plus 2, x plus 2, and these both go away. So we end up with x plus 2. Let me go a little higher because we're going to run out of room. X plus 2 times x minus 3 plus 3 times x plus 6. Okay, we got to FOIL this bad boy. First 2, outside 2, inside 2, last 2, and then plus 3x plus 6. Okay, I got only one x squared. Minus 3, minus 3 and plus 3 are going to cancel. So we'll just be left with plus 2x. And minus 6 and plus 6 are going to cancel. So that's it. So how do we find the solutions of this? We factor. So the solutions for this one is x equals 0, and the solutions for this one is x equals minus 2. We are brilliant. We make a good team, you and I. Now, we got to check to see if these are extraneous. Can I use x equals 0 up here? No, I can't. It's going to blow up right there. And it's going to blow up right here. It's going to put a 0 in the denominator in 2 places. And x equals minus 2, can I use that? Nope, can't use it here, can't use it here. So neither of these are solutions. So for this equation, the answer is no solution. Okay, no solution because both answers are extraneous solutions because both answers cause us to divide by 0 here. Doesn't matter what happens in the top. If you get a 0 in the bottom, it's dead. Can't use it. Okay? Those are the extraneous solutions. So that's really about it. It's very typical. Oh, here's one that looks exceedingly ugly that I'm not going to solve for you because it'll probably be on your homework. But this is number 13. So this is 3x over x plus 5 plus 1 over x minus 2 equals 7 over x squared plus 3x minus 10. And you look at this and you go, holy crap, how am I going to do? Look at this big old dude down here. What do you suppose the factors of this are? Take a guess. Do you think it's x plus 5 times x plus 2? Let's see. X plus 5, x plus 2. See, we get first 2, first 2, x squared, outside 2, plus 2x. Oops, I wrote it wrong, didn't I? Let me start again. You should have said something. Okay, so it's x plus 5 times x minus 2, right? It's a minus sign here, and I wrote a plus sign. So first 2 minus 2, outside 2 minus 2x, inside 2 plus 5x, last 2 minus 10. X squared plus 3x minus 10. Oh, look at that. It's the same as that. What a coincidence. It's almost always the case, or else you can't solve these things. So my advice is to write this in factored form, so when you go along and you write all the factors out, you can see what cancels, okay? These are tons of fun, and I think you're going to enjoy it. Trust me. Yeah, you don't believe me, do you? That's okay. So this is chapter 2.7. Solve these, do the homework, come to office hours, ask for questions. I'm going to do some examples during office hours that'll probably help you out on your homework, okay? Have fun.